the strategy in the troubleshooting section is really you have to get to the bottom of the ticket. You have to find the root cause of the problem. Now, usually I go rather deep into this part here, but because of those technical issues that we had yesterday, I'm just briefly going to go through a generic approach to troubleshooting that can help you a lot in the lab. The first part that you need to get right is the time management. Now, with the time management, if you have 10 tickets and you have 120 minutes for the troubleshooting section, that is 2 hours, that basically means that theoretically you have 12 minutes for one ticket. Now, the problem with that is that this is 12 effective minutes. That means that the time in the lab starts when the proctor says, okay, go ahead, welcome, you log in into your Windows, and when you log into your Windows profile, that's it. Your 2 hours have started right there. So I like to think of the lab as a person who, instead of saying, hi, hello, my name is Marko, can I please poke you in the eye? Watch out, here it comes, and then pokes you in the eye. The lab is basically one of those people who just says, hi, and then bang, right straight into your eye with the finger. So there is no warning, there is no warm-up period, there is no part of the lab that tells you, hey, arrange the planets in their distance from the sun, just like we have in other Cisco exams. There is no warm-up period in the lab. The lab starts immediately. So these 12 minutes here are a little bit of a lie. If you spend 12 minutes on tickets 1, 2, 3, 4, 5, 6, 7, you're probably going to run out of time by the ticket number 8, 9, or 10. So what you need to do is you need to be careful how you manage your time. So my recommendation is don't think that you have 12 minutes per ticket. Assume that you have 8 minutes per ticket. That gives you around 4 minutes of grace period for each ticket. Now, how should you approach the tickets? Well, the first thing you do is similar to an example that I've shown you yesterday. You've seen this table. This is the whiteboard snapshot that I used yesterday, in which I said, okay, let's say that we have 10 tickets here, and let's say that these are the point values. This is the same thing you should do for yourself. So just on a piece of paper, create this simple table. I like to call it my TPS report. And just call it, it's a ticket, point value, and status. It should take you about 30 seconds to create this table. When you log into your profile, there will be a web browser window that will contain the diagram, the troubleshooting diagram that you will be working on. And there will be a button there that, usually a big yellow rectangle that says, click here to start. Click there to start because it will give you important information about the lab. It will give you the introduction, the rules, the do's and don'ts, and what are the general guidelines for the lab. But also it will show you the link, or maybe it will be actually included at the bottom of that text. It will be the text of all the tickets. Or you might have a separate button that says, click here to see all the tickets. Click there and just quickly scan through all the tickets. Don't read them through. The only thing that you're interested at this point in the lab is to see what is the point value on individual tickets. So you just quickly scan through these tickets, collect the point value, and write them down in the table. Now, the way we are going to use this table is when you start working on something, I like to mark it. I just put a very simple dot there. This tells me, okay, I have started working on this ticket. When I complete this, I'm going to mark it as complete. So as I'm going through the lab, this might be what I end up with after spending 8 minutes on each ticket. Now you can see here that I managed to complete tasks number 1, 2, 4, 6, 9, and 10. But what remains are 3, 5, 7, and 8. Mind you, I have spent only 8 minutes on each of these tasks, which leaves me some time to go into round 2. So in round 2, I'm going to go for the highest value ticket. This is this 3-pointer here. So this is what I'm going to attack next. I'm going to go there, going to try to get this 3-pointer. But remember, depending on how much you have left, you will not have more than 4 minutes per each ticket. But try not to use all 4 minutes. Try to use a little bit less. Let's say spend additional 2 minutes, or you may want to allocate all 4 minutes. With a little bit of luck, you might get 2 rounds like this, or you might even get 3 rounds, because think about it. This is assuming that you have spent 8 minutes on each and every ticket in the lab. But some of the tickets, let's say for example tickets 9 and 10, took you only 4 minutes each to solve, which means that we will have more time to spend on round 2. But it's very, very important that you manage the time in the troubleshooting lab. Now, the only indicator of how much time you have left will be in the upper right part of your web browser. There will be a countdown timer. It's very unobtrusive, and it will not tick, it will not ding, it will not beep, it will not give you any indicator that time is running out, other than, I believe, at around 2 or maybe 5 minutes before the end of the time, it's going to turn red. And that tells you that, well, you have a 2-minute warning, that the time might be running out. When the time runs out, that's it. You will be disconnected from the server on which your equipment runs, and you will no longer be able to do anything in the troubleshooting question. Is this clear enough? Do you have any questions, any comments? Can we assume that the tickets are independent? Well, it's a very good question. Yes and no. So Cisco's official stance is that tickets are independent. But they also say that due to the nature of networking, some dependency between the tickets is to be expected. Which in plain English, if you ask me, means yes, there will be some dependency on the tickets. But they promise that if you solve the tickets in the order in which they are presented, you would have resolved the dependency before you encounter it. So it's a bit weird position from Cisco. They say it's independent, but then they say, yeah, there might be some dependencies, and yeah, just solve them how we listed them, and you will be fine. Well, that said, from my experience and from my discussion with the people who are involved with the Cisco program, with Cisco program managers and people who are actually working on the exam, the way it works is, let's say that you have tickets 1, 2, 3, and 4. What might be is that you have situation that ticket number 3, for example, depends on ticket number 1. But what you will never have is the situation that you first need to solve ticket number 3 in order to solve, for example, ticket number 1. So this dependency here will not exist. This dependency here might exist. And if there is a dependency like this, it's basically maybe a 4-point ticket that is split into 2-point parts. So it's one giant problem that was actually divided in half. So let's say that one part deals with the layer 2 aspect of the problem, and the other deals with, for example, layer 3. So you will have maybe a switch that has some devices connected there, and then there is a problem with that switch configuration, and then on top of that there might be a routing problem that you also need to resolve. So if there are dependencies, they will be like this. So this goes back with my suggestion that you write down this table like this, because if you start solving tickets in the order in which they are presented like this, you will also resolve the possible dependencies that might be included with these tickets. If I can't resolve one ticket, can I just move on to the next and just skip the previous ticket? Well, you can, of course, but if there is a dependency like this, in that case, you might run into some problems. But again, from my experience and from what Cisco people have told me, it will be obvious when there is a dependency, right? So you will know that, okay, if I don't solve this ticket, I might have problem solving something else down there. It is not going to be extremely vague and ambiguous where the dependencies are. It will be relatively obvious. And I can tell you one thing. So in the lab, in the troubleshooting section, what you are going to be dealing with is very, very large topology. It's going to be something around 35 devices. That means routers, switches, and frame relay switches, basically routers configured to work as frame relay switches. Now, if you have such a large topology, one of the reasons why Cisco has such a large topology in the exam is to make it easier for them to have tickets independent from each other. But that means that if you have this large topology that has devices and routers and switches all over the place in this topology, and you have two tickets that are concentrated in this area here, for example, well, you can be pretty sure that there is some dependency going on. It is very unlikely, or I find it unlikely, that you will have a ticket that deals with the problem here and the problem here, and that there is a dependency between them. Because then, well, I mean, your failure domain is the entire network, and to solve 10 tickets in a 35 devices large network in 2 hours could be a little bit stretching the abilities of anyone, much less the stressed out CCIE candidates. So this is not something you will encounter. But if you see the problems grouped in a relatively small part, in a small area of the network, this is where you might expect to see some dependencies. I explained how generally you can go through the tickets, how you can manage your time there. But more important thing is, how do you actually approach the troubleshooting? Well, you know, some people say that troubleshooting is art. I fundamentally disagree with that statement. Because you see, you cannot teach someone art, or you cannot learn art, because art involves a lot of talent and hard work on top of talent. But no matter how much I try to sing, I will never be a good singer because, well, I'm just not a talented singer. So trust me, I don't want to demo that, you don't want to hear that. Also, I don't know how to paint, I don't know how to draw, but I know how to troubleshoot. And it's not an art, it's a craft. It is something that can be learned. It is something that with enough practice, anyone can be good at, including me. Now, all throughout my professional life, when I was working in production networks, when I was a network engineer for ISPs, I was always dreading the troubleshooting. It was one thing that was giving me the most trouble. And because it was giving me so much trouble, this is something that I really, really wanted to learn. This is something that I wanted to be good at. And as time went by, I noticed that everyone in my team turns to me for troubleshooting. And I was the one thinking that I'm bad at troubleshooting. And as it turns out, I was actually pretty good troubleshooter. And this is one of my big strengths professionally, is I'm a very good troubleshooter. I can notice things that are out of place. Why? Because I have spent so much time focusing my professional attention on that, because I thought I wasn't very good at. So given that, if I could have learned troubleshooting, anyone can. In the CCIE lab, it is important to go into the troubleshooting having an idea, having a plan, how are you going to approach troubleshooting. So I'm not going to give you examples here. If you have OSPF, do this. If you have EIGRP, do that. If you have that, do that. Because I disagree with that kind of quick fire approach to troubleshooting. What I more believe in is a structured approach to troubleshooting, a generic formula for troubleshooting that you can apply to any technology, given that you know how technology operates and why it works the way it does. So what I always do when I start troubleshooting is, number one, I try to reproduce the problem. In the CCIE lab, this is actually not going to be that difficult, because what you're going to have is a description of the problem, which could be very detailed, as for example R19 and R22 cannot form OSPF adjacencies because there appears to be something wrong with authentication that should have been MD5. Now, if you have a ticket like that, those are 3 points because they actually told you exactly what's wrong. It's the OSPF, it's the authentication, it's the MD5 authentication, doesn't work, so you know exactly where to go. So reproducing the problem is basically just looking at the log message, what happens. But what if you have a more realistic, more real-life-like question? Internet is broken. Oh, sorry, your internet is broken, which is what users usually tell you, or what I was telling on the phone yesterday when I had internet issues. Now, when you have a vague description of the problem like that, anything that you can hold on helps. Now, this is where the CCIE lab is different than the real world, because in the CCIE lab, what you are going to have is the description of the problem, your internet is broken, and then below that there is going to be a verification command. Something along the lines that when you have completely solved this ticket, this command should produce the following output. And there will be an example of the command and there will be an output. This is your reproduce the problem step. Run that command and observe the output. Now, that command could be telnet, could be ping, could be any command imaginable. And here is the thing. At the end of the ticket, anything in that output that you can match, you need to match. So for example, if it says show IP route EIGRP and shows one route, and you do show IP route EIGRP and you're showing 17 routes, you have not solved the ticket correctly, because you are showing 17 routes when their sample output shows a single route. If you see a route, you need to match the metric, you need to match the next hop, you need to match anything possible about that route, but be reasonable. There will be an entry there in the output of, for example, show IP route, how long time ago this route was learned. There is no possible way you can match that timer, so don't even try. Or for example, in MPLS VPNs, if they give you a trace route, in those trace routes very likely you're going to see the label values. Don't try to match those. You can match those using static labels or very, very lucky random assignment of dynamic labels used by LDP and TDP, but that would be a complete and utter waste of your time because nobody really expects you to match the actual label values. What they want you to match is the path the traffic takes and the fact that it's label switched, but not necessarily which label values were used there. So as I say, you need to match that output exactly, but be reasonable about it. There are things that you cannot match or that would be extremely difficult and no one expects you to match, but everything else needs to match correctly. So step number 1 is reproduce the problem. Why? Because you can have a situation in which, for example, R1 cannot ping R15. What's the first thing that you have to do? You run ping. And when you run ping, you're getting destination host unreachable somewhere, right? You're getting back unreachable messages. So you're not getting dots, you're getting unreachables. That means that someone along the path doesn't have the route for it. So you can go and look for that. It's probably not the device on which you are pinging. It's probably not the device you are pinging. It is something in between. If you try to ping and it says no route to host, well, ping won't do that. But for example, if they give you a request that R1 needs to telnet to R19 and you try to telnet and it says no route to host. I mean, don't spend your time looking at is telnet configured on R19, is it properly authenticating me, whatever. That's not the case. You don't have the route on R1. Or also if, using the same example, if R1 cannot telnet to R19, and if you try to telnet from R1 to R19 and it says connection refused, don't waste your time looking for missing routes for misconfigured layer 2. It's R19 that's refusing you the telnet, right? So you go to R19 and see what is the line configuration. Is it accepting telnet sessions? Why is it refusing your telnet session? So this is why reproducing the problem there is very important step, because it might push you in the right direction with the troubleshooting. Now, in many cases, you are going to get useless output. R1 cannot ping R19, you ping and you get 5 dots. well, that means, yeah, it's broken. But what is broken, you don't have any indication where to even begin troubleshooting this. So you have to take it one step at a time. Now, what I mean by one step at a time is, I like to call this part work the layers. And here I, of course, mean network layers. But I don't mean OSI network layers, because 7 network layers, that's a little bit of an overkill, because first of all, we are not running OSI networks, we are running TCP/IP networks, we are running IP networks, and this is what you will be troubleshooting. So there is a TCP/IP network model that consists of 4 layers. And those layers are application, we have network layer, there is data link, and there is a physical layer. Now, work the layers means either start troubleshooting from top down or troubleshoot from bottom up. Now, good news is that in the lab, you will not have any physical layer issues. Nothing that can be solved or resolved by shutdown or no shutdown will be an issue. One of the reasons for that is that the entire troubleshooting lab is running in virtual environment. It's running on Cisco's IOU. Well, these days it might even be running on Cisco's Viral, but I believe it is IOU still, which means there is really no physical layer between devices because they're all emulated entities on a single server. Also, IOU has trouble maintaining the not trouble maintaining, but because there is no real physical layer, IOU emulates the physical layer. So let's say that you have 2 devices, R1 and R2, that are supposedly directly connected on their Ethernet interface. The way it actually works logically inside the emulator is that R1 is connected to a hub and R2 is connected to a hub. And this is what provides their connectivity. So they're not directly connected to each other, which means that when you shut down the interface on R1, basically you're shutting down the interface to the hub, which means that this shutdown interface will not reflect on R2. So you might have a situation that you have what appears to be directly connected devices, you shut down one side and the status is not reflected on the other side. The same thing for serial interfaces. Even though they appear to be directly connected back to back, there is an emulated modem in between them. So when you shut down this side here, what is happening, you're shutting down the interface to a virtual modem, and it may not reflect on the other side. For these reasons, Cisco will not test you on any failures that involve this kind of resolution. So don't shut down or no shut down, this is not the problem. And physical layer will be okay, mostly because there isn't physical layer in existence in your troubleshooting lab. So what you need to do is you need to focus your attention on these 3 layers here: the data link, the network layer, and the application layer. When it comes to the data link, of course, all layer 2 protocols are fair game. You might have PPP, you might have HDLC, you will have frame relay, you will have Ethernet. Now, when it comes to frame relay, and because this is one of the stumbling points that I have students struggle with a little bit, in that large topology of 30-35 devices, some devices, 1, 2, 3, 5, 10, 15, God knows how many, are going to be frame relay switches. Frame relay switches are a fair game for misconfiguration, which means that it's not an untouchable entity in the troubleshooting lab. If you can connect to it, if you can log in, and if you can enable on the device, it might be the problem. That means that if you have a device, let's say R1 and R2, and there is a frame relay switch in between them, and you cannot get connectivity between R1 and R2, don't assume that the frame relay switch is correctly configured. It could be misconfigured, and it could be something that you need to fix. Also, in the configuration part of the lab, it's also a fair game. You might need to configure the frame relay switch. Now, probably not, but it's good knowledge to have when you go to the lab. If you ask me personally, frame relay has no business being in the lab. Frame relay switch, what were they thinking? But it is what it is. This is what we have to deal with. It is 2013, and unfortunately I do have to talk about frame relay. I had, in my previous class, I had a student who really thought I was joking when I was talking about frame relay, and they thought I was wasting their time, but you know, frame relay is in the lab, unfortunately. It will probably be gone in the next blueprint, but by that time, I hope you're all CCIEs. So, going back to the troubleshooting. Work the layers simply means make a decision where you want to troubleshoot. Are you going to start troubleshooting from bottom up? That means, are you going to first look at PPPH, DLC, frame relay, Ethernet, whatever is running there, and then work your way onto the network layer, which would be, of course, your routing protocols. And here we are mostly talking about RIP, EIGRP, and OSPF, and then go to the application layer. Now, you might have noticed that in my previous sentence, I said RIP, EIGRP, OSPF, but where is BGP? Well, in my opinion, most of BGP-related issues are actually application issues. So I like to always approach BGP as not really a routing protocol. It's something else. It's a policy implementation protocol. So I always think of it as, okay, it's an application that needs to run on already functional network. Yes, it provides the routing. Yes, it provides the routing information. But if you approach it more like an application, you will be more successful in troubleshooting it. Also, sometimes those other three routing protocols that you will have in the lab are also applications. An example, let's say that you have an adjacency forming between R1 and R2, and this is supposed to be EIGRP. Now, this EIGRP is not coming up because EIGRP password is misconfigured. Now, when you look at this relationship at its atomic level, that means we have only two devices with the link in between. Is there a layer 2 problem between them? No, there isn't, because they can communicate. Is there a layer 3 problem between them? Is there a network layer problem between them? Not really, because there is end-to-end reachability between them. What is failing is the application that needs to run in the network consisting of two devices. And this application is EIGRP. So you need to fix the application called EIGRP. You need to fix the authentication in order to probably solve a much larger connectivity issue. But when it boils down to only these two devices, it is an application layer problem. So when you look at the problems, when you look at the description of the problem, you have reproduced the problem, you need to make a decision which way you want to go. But sometimes, you know, due to our experience of years and years of working in networking, we sometimes get that gut feeling that when you have seen what the problem is, when you have tried to reproduce it, when you know, you sometimes just have this urge, this feeling, hey, I think I know what's wrong here. Now, this gut feeling, this experience message coming deep inside from you, listen to it, because that's the third valid approach to troubleshooting. I like to call this one split and divide, when you basically just go directly into a layer. So you're not working the layers up or down, you go directly and try to solve the problem. Listen to that voice in your head, because it might be right. Now, it very often happens that we go with our hunch, we go with our gut feeling, we go and check it out and clickety, clickety, click, and we go there and it's not that. And then we get another hunch, another gut feeling. And you know what that other gut feeling is? It's called guessing, right? At this point, it's not a gut feeling. At this point, you are just stumbling in the dark, trying to figure out where the problem is. Don't do that. One hunch per ticket is allowed. If you want to run multiple hunches, that means that you're just trying to guess what the problem is, and you are, trust me, not going to be very successful with that. But listen to that experience speaking once per ticket. Now, once you have gone through these working the layers, inevitably you are going to find and pinpoint where the problem is. When you have found the problem, the third step is fix the issue. Fix the problem. Now, fixing the problem may sound easier than it actually is. The reason why it may sound easier than it is that in the CCIE lab, you are expected to fix the root cause of the problem. You are not expected to fix the symptoms of the problem. Now, sometimes it might be rather difficult to fix the root cause and not focus on the symptoms. This is why I always like to tell my students very, very horrible example. Imagine that I was in a car accident and that part of my body is missing. Let's say my arm went missing. And somebody comes to me and says, oh, your arm is missing. Here's an aspirin for your pain. Basically what they are doing is they are fixing the symptom of my problem. Not the fact that I no longer have arm. No, that's probably unfixable unless we can find the other parts, but let's not get that gory right now. But this is the same thing in the lab. Don't go chasing symptoms around with a pill of aspirin. What you need to do is you need to find the root cause and you need to fix it. Now, how should you fix the problem? Well, your solution, and this is a quote from Cisco, your solution needs to follow the spirit of intended configuration. Now, whatever that means, my understanding of follow the spirit of intended configuration is do not remove anything that has been configured, make only minimal changes, and your changes must be in line with what's already configured. An example of that would be, let's say that you have, again, R1 and R2, and you have some trouble communicating between them. You go through your layers and you find that there is an access list blocking this configuration. And you look at the access list entries, and they say something along the lines of permit ICMP any, permit UDP any, permit TCP any. Something like that. Maybe not that generic because that would really allow everything. But let's say it was permit UDP any and permit TCP any, and you cannot ping, which obviously means that ICMP is missing from the mix. So your access list in this case is perfectly fine to include permit ICMP any. Why? Because it kind of follows what's already configured. It follows the spirit of the intended configuration. But let's say that you have an access list that says permit TCP host A, host B, permit TCP host A, host B equals that, permit UDP host, and then the port numbers, permit this, permit that, and the task says, oh, SSH between hosts A and B is not working. So obviously you need to add SSH. Completely wrong configuration in this case would be to say permit TCP any equals SSH, or permit IP any. That would be solving the symptom, because your solution there does not follow the spirit of the intended configuration. Because all other rules in that access list were very, very, very specific. The obvious intention was to lock the network down to allow only permitted traffic and deny everything else. And what you are doing with your solution is permitting everything, right, and not following what was the intention there. So you need to be careful about this. When you are trying to solve the problem, follow the spirit of the intended configuration. Another thing that you need to be very, very careful about is don't get too creative. So this is the example that I always like to tell. Again, R1 and let's say R19, somewhere very, very far, and there are a lot of devices in between. Each device has a loopback interface. There is a loopback 1 on R1 and there is loopback 19 on R19. The task says make sure that R1 can ping 19, 19, 19, 19, which is the loopback address on R19. What is the easiest solution for this task? Well, the easiest solution is to create a loopback interface on R1 with IP address 19, 19, 19, 19. So forget about the network here, forget about the router 19, just add the loopback on R1 because the task says that R1 should be able to ping this address. Now, this is an example of being very creative. And this is not the correct solution, obviously. But this is the example of being creative with your solution. Well, technically speaking, you have satisfied the requirements of the task, but you have not actually solved the problem. Why? Because there is no communication between R1 and R19, which is what they wanted to do. And this is one thing that I see people struggle, not this extreme example that I've just given you, but I've seen students struggle with this idea that, you know what, yes, this is a lab, but it kind of emulates the real network. What we are trying to do here is to put in a lab environment, in a testing environment, to put a situation that you might encounter in real life. When in real life would you solve the problem of communication between R1 and R19 by adding a loopback interface on R1 to emulate R19? Well, never. So don't do it in the lab. Also, keep in mind two things. First, you are initially going to be graded by a script. The script doesn't know who you are, where you are from, what your background is, and it doesn't know what you were thinking at that time. It just says, okay, this was the task, this is the output that I expect, this is the behavior that I expect. Am I getting it, yes or no? If the answer is yes, you get the points. If the answer is no, you're not getting the points. Now, the results from the script will be reviewed by a human grading proctor. Again, the proctor doesn't know who you are, doesn't know your background, doesn't know your experience, and doesn't know what you were thinking. The only thing that the proctor has is the output from the script. Now, if you are very close to passing the test, let's say a couple of points, the proctor is really going to try to find the missing points. But if the script tells him that your overall score is 4 points in the troubleshooting, do you think that the proctor is going to spend any time looking at any other tickets? No. Even though your solutions might have been very, very correct, but they were so creative, so not mainstream, that the script declared them as wrong. But when the script declares so many tickets as wrong, the proctor simply assumes you have no idea what you're doing. So don't fall for this trap. Now, again, a disclaimer here. It is very, very likely that Cisco has actually gone through the trouble of finding many alternate solutions for different problems. So there is not a single correct solution. There are probably multiple correct solutions for almost all the problems they give you. But you can still get very creative and miss the points there. So what makes you good at troubleshooting? That was the question. What makes you good at troubleshooting is, I think you have to develop the ability to see the connections between things. The CCIE lab or any network is never, a simple, straight, linear progression from A to B, because there are so many things that are happening at the same time. So what you need to do is you need to work on your ability to look at a slightly bigger picture in the network. What are the protocols running? What are the interactions? How does this technology interact with that technology there? So I've met people who are very, very, very good at one thing in networking. Like, for example, I had a couple of classes with Cisco TAC, and whenever I'm with TAC people, they are very good at what they do. So if I have layer 2 team, they're going to bounce me around like a ping pong with questions about layer 2 because they have seen it all. It comes to layer 3, So we enable EIGRP by router. How do you spell router again? I'm, mimicking it a little bit. It's not exactly that bad, but it's borderline there. So they're very, very good at one thing, but they're not very good at some other things. So what makes you a good troubleshooter is having a good overall command over the technology that okay, if I configure this thing here, it might affect that other thing there. And then when you encounter an unknown network or you encounter a problem, you need to develop this ability to kind of grasp, this is what's happening, these are the symptoms, what other technologies I have, what other technologies that exist in the network could be causing this. Because in many cases, you're not going to have a problem with a single technology. It will be something else influencing it. One of my pet peeves is private VLANs, for example. Now, private VLANs, we pretty much all know what they do. They kind of isolate some devices from the other devices, and that's relatively easy to understand. But what do they do for routing protocols? What do they do for OSPF, for example? Do you know? Give it a try. Give it a thought. I'm going to give you the answer. They create hub and spoke. So on Ethernet, which is broadcast multi-access, you are creating a hub and spoke environment. So all the behavior that we have in, for example, frame relay, when you're dealing with OSPF or eIGRP or RIP, we now have on Ethernet. So we have to worry about all those things. For RIP, we need to think about split horizon. For eIGRP, we need to think about a split horizon. For OSPF, we need to think about the DR placement. Because if we don't think about those things, we are going to have reachability issues because spokes will have trouble communicating to each other. So these are the things, these are the interactions that you need to be able to spot, that you need to develop this skill to spot. How do you develop it? Well, there are, in my opinion, and terrible cliches now coming up, 3 pillars of success there. One is you need to develop your knowledge. How do you gain knowledge? Well, you gain knowledge by reading books. There is no replacement for that. You are going to listen to audio training, watch the videos, attend live classes, do the labs, right? You need to broaden the knowledge. Because I had an example in which I would be explaining what was wrong in, for example, one ticket in one of my classes. And a student would raise a hand and say, yeah, but you have to know that to solve this, right? Well, the answer is yes. You have to know the technology. You have to know how it works. You have to deeply understand it, right? Because if you don't know something, no matter, I mean, it's not enough to know how to type. You have to know what to type and where and when and why, not only how. The second thing is you need to have experience, right? The experience comes from actually doing stuff. It's one thing to read about technology, and it's very, very different thing to implement it. As they say, in theory, there is no difference between practice and theory, right? If you read something in the book, that means that you can do it tomorrow. Well, not exactly, because, you know, there are things like timers that you might read in the books about, but they don't actually register until you see them in action. For example, you're bringing up 2 interfaces, you want the communication to go there, directly connected switch and a router, you want to ping across, and it doesn't ping. Why doesn't it ping? Well, because there is spanning tree. It takes time for spanning tree to do its magic. Well, that's it. You know there is a spanning tree. You read it in the book, but now you are actually seeing it in action. Now you understand what those timers actually mean. Or, for example, we all know from books that there is a 180-second hold down timer for BGP. Okay, 3 minutes before BGP figures out something's wrong. But the way you're going to see it in the lab is you configure something, everything works fine, you move on to another task, and what happens? After 3 minutes, that session that you just configured, bam, goes down. It takes 3 minutes for the routers to notice that there's something wrong. But you as a human, you look at the session seems established, you are getting the routes here, you're getting routes on the other side, everything's fine, moving on. And not everything is fine because, well, the keep alives are not being sent and received, and the hold down timer is 3 minutes, which means that it is going to expire at some point and you may or may not see it. So this is one thing. You need to have experience. You need to have seen those things. And the third, and this is the most important if you ask me, is the self-confidence. You need to believe that you can do that. You need to go into the lab, or even in your daily work when you're troubleshooting something. You can't approach the problems, oh, what am I going to do now? I don't know what to do. Should I touch this or not? No, you have to go in there with a fighting attitude. Bring it on. You walk into the lab, you look the proctor in the eye, and you say, bring it on. Well, don't do that. They might take it the wrong way. And at least one of them is very good in Kung Fu, so you might have trouble with that. So, you know, don't actually express your fighting mood, but be in that mood. Anything they have, it's just work. So when you see the lab, when you get that web page with tasks, with diagrams, with things to do, you just have to go, okay, I know how to do this, done, 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 done. Oh, this one requires a lot of typing. You see, requires a lot of typing. That's it. It's just work. It's just something that needs to be done. There is no difficulty. Why? Because you know this stuff, you have seen it, you've done it in the lab, and you know you can do it. So these 3 things are what are going to make you a good troubleshooter and a successful CCIE candidate. Successful CCIE candidate is the one who signs his emails with a CCIE number, just so you know. As I said, fix the problem. Don't get too creative about fixing the problem. And last but not the least, and this is very, very important part, verify your solution. How do you verify? Well, at least you should run whatever command Cisco gave you and said, okay, this is what is going to be, this is what needs to happen at the end, run this command, and if you get this output, that's pretty much it. Now, keep in mind that this is probably not the only thing that will be used to verify if your solution is correct in their grading script, but this is the least you can do to verify. Of course, you would want to, sanity check everything that you have done and make sure that you didn't break any lab restrictions, which might be in place. And once you are done, once you are happy with how that works, don't spend too much time on this. You have to verify, but don't spend 15 minutes verifying a 30-second ticket. After you're done, is save the config and move on to the next ticket. Now, one question that I often get asked, and this is usually by the people who have recently gone through a, say, CCNP certification where there is a troubleshooting test there. Here you can actually go back and forth because these tickets are not happening on separate topologies. This is all in one big topology, one big network, and your tickets are just text. So there is no really going back and forth between the tickets. You are not closing one topology and opening a new one for the next ticket. So yes, you can freely move anywhere you like with your lab progress. There is really no structured, okay, you are now on ticket 1, this is the environment, these are the tickets, these are the devices, and when you are done, you are done. It's just one big environment. There is one thing you should not do in the troubleshooting section. In the upper, I believe, it has been a long time since I have seen the lab with my own eyes. I believe when I was taking it, it was in the upper right corner, there is a button that says finish section. Now, finish section doesn't mean that you are done with ticket 1, you want to move to ticket 2. It means you are done with the troubleshooting. When you click on that button, there may or may not be a dialog that says, are you sure you want to finish the session? If you click on yes there, that's it, you are done with your troubleshooting. If you do this after the first ticket, enjoy your lunch in RTP or Brussels or wherever you are taking your lab, because that will be pretty much the only thing you will be enjoying that day, because your session is over at that point. Now, you should click that button when you are really truly done with the session. There are 2 hours allocated for the troubleshooting section. You cannot exceed these 2 hours, but if you finish earlier, and I know people who have finished earlier, when I was taking the lab, I was considerably under 2 hours with my troubleshooting. I actually clicked that button to move on to the configuration section, because all the unused time from the troubleshooting section you can actually use in the configuration section. I like to think of it as QoS, where troubleshooting section is LLQ. You can use up to this time, but anything that you don't use can be used by other section or other queues. So it's CBWF queue for configuration section and the LLQ for the troubleshooting section. So you can use that time. Now, mind you one more thing. If you have only, let's say, 5 or 10 minutes left in the troubleshooting section, don't rush to end it. Because those 5 minutes would be, in my personal opinion, better spent verifying 1 or 2 of the tickets than actually using them in the configuration section. But if you have half an hour left and you have verified everything and you are happy with your troubleshooting, those half an hour can actually get very, very useful in the configuration section. So, that said, let's talk a little bit about the configuration section. In the configuration section, you are going to have, as I said, a minimum of 6 effective hours for the troubleshooting. You are going to have whatever remains from 100 points. So if here we had 22 points, here we are very likely to have 78 points allocated for the session. And in how many tasks? Well, that heavily depends on the lab that you are actually working on. But I would expect to have somewhere between 25 and 30, even though 30 is a bit high number for that, gradable items. Now, let me explain what a gradable item is. Gradable item is also something that we like to call a question. And any gradable item, any question, can have any number of bullet points. So just like the lab that you have been working on yesterday, where you have, for example, task 1, do this and this and this and this and this and this, and then multiple bullet points there. That 1.1, that's a gradable item, and then you have multiple bullet points there. The gradable item is the smallest amount of points you can get for those allocated tasks. So if you have a gradable item that has, for example, 5 bullet points and carries 4 points, there is no way in that gradable item that you are going to get 1, 2, or 3 points. It's either going to be 4 points or nothing. And you can get 4 points only if every single requirement of that task has been met. Which brings me to the most important thing about grading in the configuration section. No partial credit is given, right? Just what I said. And also, that means that the more gradable items you have, the better it is for you. Because the last thing you want is to have 10 questions of 7 points each. That means that there are a lot of points to lose if you miss a single bullet point. The best possible lab that you can have is the lab that has 78 gradable items that each carry a single point. That will not happen, but that will be the best scenario. Because that way, if you lose something, you're losing only 1 point. If you miss one little requirement, you're losing only 1 point. But if you have large questions that carry, for example, 4 or maybe 5 points, well, if you lose 5 points on 78, you're very, very close to not passing that test. The same thing as in troubleshooting section, you need 80% of the points in order to pass this section. Only when you have gotten 80 points here and 80 points here can you be called a CCIE. Now, before some of you ask, yes, you have to do it in one sitting. That means that if you pass troubleshooting section in one exam and fail the configuration section, and then you take the test again and you fail the troubleshooting and you pass the config, unfortunately, you are not yet CCIE, because I had students who thought they were CCIEs, or they considered themselves CCIEs because they have passed both sections, just not at the same time. So yes, you have to do it at the same time in one sitting, unfortunately. It would be nice if you could kind of store your troubleshooting so that you are CCIE routing and switching troubleshooting unless you actually pass the configuration, but it doesn't really work that way. So as I said, you need 80% of the points in the troubleshooting and the configuration to pass the lab. The challenges in the configuration section are very, very different than the challenges in the troubleshooting section. First thing is the point distribution. In the troubleshooting section, we have these 3 pointers and 2 pointers. In the configuration section, we can have 4 pointers, 5 pointers, 3 pointers, 2 pointers, and 1 pointers. So we can have really large number of different point scales. So let me just fix this very quickly to at least have some resemblance of order. So there can be any distribution of points per individual tasks. It's not only that you will get 2 pointers or 3 pointers. Now, of course, 5 pointer will usually have considerably more work than 2 pointer, but don't underestimate 2 pointers, 3 pointers, and 4 pointers. They will have a lot of work. Sometimes you're going to have a 2 pointer that has considerably more work than another 4 pointer, but 4 pointer is going to be more difficult, more challenging than the 2 pointer. A 2 pointer just has a lot of stuff to be done, but most of it is copy paste. An example of that would be in, say, layer 2 section, where they ask you to configure ports as trunks and access ports and whatever, and you just have a lot of work, but it's mostly copy paste. This could also be a 4 pointer that is not terribly complicated, but it has a lot of work, and Cisco recognizes that it has a lot of work, but be careful about that. You're actually better off if you have these long, tedious tasks that have low point value than if they have high point value. Why? Because if you have a task that requires you to do multiple configurations on multiple devices, and if you make a single mistake, isn't it better to just lose 2 points than lose 4 points? So sometimes you're going to look at this task and you're going to say, oh man, this is a lot of work for just 2 points, when Cisco is actually doing you a favor, because they know that the likelihood of you missing a single thing, and missing one little requirement on one of those places, in one of those places, is very likely. So Cisco is saying, okay, if you lose these points, we are just going to penalize you very little. So it's very different than you looking at it and saying, oh my God, look at how much work I have to do for 2 points. Cisco is actually doing you a favor. They're looking at it from other perspective. They know you're not going to do this right, or that there is a high likelihood of you not doing this right, so they don't want to penalize you much, because it's not really that important in grand scheme of things. If you miss one, say, spanning tree port fast on one of the ports, one of 15 that you configured, right? So there is sometimes going to be this disbalance between the amount of work and the point value, but it also has to do with how much Cisco wants to penalize you if you don't get it right. So there are two angles from which you can view this unusual situation. But 3-pointers and 4-pointers, they are usually going to be indicator of, okay, this is going to require some brain power. Now 5-pointers are something that legend has it, that there are rumors about for routing and switching. Personally, I can tell you that in all of the exams that I have taken when I was taking the CCIE RNS, and I took it 3 times, I have not seen a 5-pointer. Now, I have heard it once or twice from students that they were all scared that they've seen a 5-pointer, but when I asked them, are they sure, they say, well, it could have been a 4-pointer, I'm not sure now. So, be on a lookout for it. It would be good to get it right, because take a look. If you lose 5 points on 78 points in total, you're not losing 5%, you are losing 6.5% of the points, and you are getting close to that 80%. You don't have a large margin to begin with, maybe 3, 4, at maximum 5 questions, but I would say 3 or 4 questions is your margin of error that you can feel comfortable about going into the lab. Anything above that, you are in the territory of you're most likely not passing on that day. But as I said, the challenges in the configuration don't end there. Another challenge is that you are going to be stuck with the same devices for 6 hours. And for the version 4 of the test, the one that you will be seeing, the configuration section is not virtual. It is actually happening on the real equipment. And this real equipment consists of 4 switches, and these are 3560 switches, and 5 routers. And the routers are a combination of 2800s and 3800s. And I'm not sure, so let me just write it here. There could be that they might actually have some 1800s. So again, relatively old equipment, but it runs everything that you need to run. For those of you who are curious, 3560s will be running 12 to 44 or 46. The differences are minor. SE version of the code, it could be any sub-release of this code, and the routers will be running 12.4 15T, and again, it could be any sub-release of this code. So these are going to be the 9 devices that you're going to have under your control, and there could be any number of backbone devices. Now, backbones are operated by Cisco. You do not have access to them, so I'm just going to say here that you do not have access to them, and it is very likely that they are going to be 3550 switches in your lab. So you don't have to worry about which backbones they are using, but one thing that I want you to keep in mind is that it might be a switch. So if they require you to do something on your side, like for example, they say don't send any BPDUs to the backbone, keep in mind that if it's a switch on the other side, if it receives BPDUs, and if it has, for example, BPDU guard configured, you are in trouble if you send any BPDUs. So try not to do that. Also, the actual physical wiring in the lab, for those of you who have Cisco 360 training material, and I think our material is better just for the record. The wiring in the real lab is going to be the same. So you're going to have 4 switches. So this is going to be switch 1, switch 2, switch 3, switch 4, and there's going to be a full mesh of 2 links between each of these switches. And this is pretty much what we have in our Proctor labs. So these interconnecting ports are going to be 19 to 24 on those 3560s. And the routers will connect to switches like this. So this is switch 1, this is switch 2. Let's say that this is router 1, 2, 3, 4, and 5. So these are the connections between them, and this is going to be port 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and this is going to be 0, 0. And this here is going to be 0, 1. Now, there is going to be any number of serial connections between the routers. I don't really know how they are done, so but let's assume that perhaps something along these lines. So as you can see here, the wiring is actually going to be very, very logical. It's not going to be illogical. They're not going to test you, you know, oh, can you figure out that R5 is actually connected to R4 port 19? They're not going to do that to you. The lab is not about this, right? So this is equivalent of me telling you the sky is blue, right? So this is how things are going to be physically wired. But it really doesn't reveal anything. It just tells you, okay, this is how it's connected. Based on this and that full mesh of switches there, any number of virtual topology, logical topologies can be built, right? So it is going to be relatively straightforward. You won't have to spend too much time figuring out how things are wired. So the question is about the frame relay switch. Well, I was hoping that someone will actually ask this question. So here on this list, do you see a frame relay switch mentioned anywhere? Well, no, you don't, because there is no frame relay switch in the lab. What you are going to have is one of these routers here is going to be configured as the frame relay switch. So frame relay switch will be device under your control. There are 2 scenarios. One, or actually 3 scenarios. One of these devices, and in my case here, the good candidate would be, for example, R2. Because if you take a look at this here, R2 has serial connections to R1 and R3, and I also drawn serial connection to R4. So R2 here is a good candidate to be, for example, a frame relay switch. Now, I'm not saying this is how it's going to be in your lab, because I really don't know the serial connections there. I never actually bothered to remember that. But as I said, take a look at Cisco 360 training. That's pretty much it. So R2 here is a good candidate. Now, scenario number 1 is R2 is pre-configured as the frame relay switch. It's configured correctly, and it's operating as it should. So you don't actually have to touch that config. Scenario number 2 is frame relay switch is not configured at all, and as a part of the one of the layer 2 tasks, let's say frame relay switch setup task or frame relay task, you are actually asked to configure R2 as the frame relay switch. So you should really know how to configure frame relay switch going into the lab. Scenario number 3 is that frame relay switch is partially configured, which means that some bits are configured correctly, some bits are configured incorrectly. Now, this is more likely scenario for the troubleshooting section, granted, but don't go into the configuration section thinking that your troubleshooting is over. In my experience as both the CCIE candidate and the CCIE instructor, the troubleshooting problems in the troubleshooting section are nothing in comparison to what you are going to do to yourself in the configuration section. The troubleshooting that you will have to do as the result of what you have done to yourself. So this is no exception here. you may need to go into the configuration section with partially configured frame relay switch. So you need to know what's happening there and how to troubleshoot and configure it. But there is no dedicated frame relay switch device, and that's a big important thing when it comes to frame relay in the CCIE lab for the configuration section. Because this is real equipment, there is real danger of something actually being wrong with this equipment. Now, this is not something that is technically speaking part of the lab. You're not expected to fix physical errors. But if you encounter a physical layer problem, for example, the connection between our R4 and R5, this serial connection here got broken, if that is the case, and you are absolutely certain it's a physical layer problem, this is something you should report to the proctor, because you cannot fix it and you cannot proceed with the lab if this link is in use. Now, you might have labs in which this link between 4 and 5 is not in use. In that case, you don't absolutely care if it works or it doesn't. But if it's in use in your lab and it doesn't work and it's not coming up and you have down on both sides, report to the proctor immediately so that the proctor can take action. They can replace the cable, they can maybe move you to a different pod, or worst case scenario, you're going to get a voucher for another retake. But it's important not to waste time on this, and even more important, don't go to the proctor reporting the problems that are part of the lab. So for example, link down. If we have link between say 4 and 5 and it says up/down, is this something you should report to the proctor? Absolutely not, because the link is up, physical connection is up, it's layer 2 that is down. That is your problem. Layer 2 is your issue. But if you have link that is down, you can report it to a proctor, but only after you have verified that the other side is not shut down. Because if the other side is shut down, that's again your problem. But if you are absolutely certain that there is no shutdown on both sides and the link is down on both sides, this is something that you should report to the proctor, because it most likely indicates a cabling issue. You can also take it one step further, do show controllers. And when you do show controllers, it will tell you that no cable is attached. And if that's what it says, there is no cable attached. If there is no cable plugged in, there is nothing you can do. I mean, this is not a wireless lab where you can communicate wirelessly. And even if it was, there would be cables attached even to the antennas. So the important thing is, notice when there are hardware issues. If you encounter hardware issues, report them to the proctor as soon as you can, because the sooner you report, the sooner they will be resolved. Now, if you encounter any sort of a hardware issue or any sort of a failure of the sort in the lab, the way it's going to work is you're going to go to the proctor and say, Mr. Proctor, something's wrong. You explain what the problem is, and then they're going to say, okay, please step aside while we troubleshoot the problem. At that point, your lab clock stops, so don't panic, right? They're not going to cut this away from your time, except if you prove to be wrong. So you need to go there when you are sure. And what's going to happen, anytime it takes them to actually fix the problem, you're going to get back, and they're maybe going to give you 10, at most 15 minutes on top of that for the time it took you to figure it out. Don't hold your breath for 15 minutes, it's usually going to be somewhere between 5 and 10 minutes. And I know it sounds scary, oh, what if this happens to me? If this happens to you in the lab, celebrate. Because if this happens to you in the lab, what just happened right there is you got more time to think about the things you need to do. Because they will tell you, step aside and don't touch your equipment. But they cannot tell you, step aside and don't think about the lab. Think about the sky, think about the flowers or something. They cannot do that. Or, well, technically speaking, they can tell you, but are you going to be thinking about the flowers? You're not. Well, now you might, that I've given you the idea, but you should be thinking about the lab. That means you should report this to the proctor as soon as you can, but be smart about it. What do I mean by that? When you start the lab, you're going to be presented with lab tasks. The first thing you should do is do the similar thing you did for the troubleshooting section. Create your TPS report. Again, this should take you maybe 1 minute. Just write down the tasks 1, 1, 1, 2, 1, 3, etc. So here we have 2, 1, 2, 2, 2, 3, 2, 4. Whatever the layout of the tasks is, and 3, 1, 3241 4243 and so on and so on and so on. Just quickly glance through it and see what is the point allocation for these tasks. For example, like this, and we are going to have more tasks than this. And then what you should do is actually read the whole exam. And yes, I mean read it in detail. In troubleshooting, there are going to be very few dependencies between the tickets. In the configuration section, there will be dependencies between the tasks. Sometimes you might need to do tasks out of sequence, out of the order. You might need to do part of one task before you can do the other task, or you might need to start 3 tasks before you can actually complete all 3 of them. So it is going to be a big ball of stuff that you are dealing with, and not really a linear progression from A to B. So what you need to do there is read the whole exam so that you can get this big picture about the exam. It's important to understand what is going on. Now, you are reading the exam for several reasons. One is to get the big picture, to kind of get the idea of what is going on. Another thing is you are looking there for landmines. Now, landmines are in the lab are just like the landmines in real life. Those are things that have been planted there to blow up in your face and to cause you serious injury. So landmines in the lab are the tasks that are sitting somewhere in later sections of the lab, sections 3, 4, 5, 6, no matter how many sections you have, that are planted there that are supposed to disrupt your core of the lab. Now, the core of the lab are sections 1 and 2. Section 1 will always be layer 2 section, and section 2 will always be layer 3 section. Now, mind you, sections 3 and 4 could also be important. It could be the MPLS, it could be the MPLS VPNs, and depending on what lab you're dealing with, this could form part of the core of your network. But sometimes it doesn't. Sometimes it's just an added-on service on already functioning network. It depends on the lab, so you need to be on a lookout for that. So maybe this forms also the part of the core of your lab. So landmine would be a task that sits here that will disrupt this thing. An example. Let's say the task 1, section 1 deals with setting up the VLANs, setting up the trunks, setting up the switching, doing all sorts of things. And then here in task 2.1, you are configuring your OSPF, EIGRP, RIP, protocols, redistribution, BGP, whatever it is there. And then task 4.3 says, oh, by the way, routers 3, 4, and 5 are in a private VLAN setup. Now, that not only changes something here, it may also change the behavior in layer 3 considerably, because you are building the hub and spoke, the full reachability may be impacted, your switches need to be changed to transparent mode, etc., etc., etc. So there are things that need to be done. So this is why we are reading through the lab to say, aha, private VLANs. You know what? I'm not going to do the private VLAN here. I'm actually going to do private VLANs as part of layer 2 setup. So that when I start going through my layer 3 section, when I configure my routing protocols redistribution, when I'm testing the full reachability, I actually already have the private VLANs configured. You can also have QoS tasks that are disruptive, you can have security tasks that are disruptive, and so on and so on. So you can have many, many different tasks that can disrupt the behavior of previously configured things. So this goes back to one question that you guys asked me before, and that is, how do you become good at troubleshooting? Well, my answer was you need to master this ability to see the big picture, to see how one technology relates to another. It's also important here in the configuration section, because it is important for you to see the big picture, to understand what is the relationship between one protocol and another protocol. Because if you are not seeing these relationships, if you're not seeing how one technology can influence another, you are going to struggle even through the configuration section, or even worse, you are going to be wasting a lot of time doing things twice, That's the worst thing you can do in the exam, to go do something and then have to do it again differently. So try to avoid that situation. Number 3 reason why you are reading through the whole exam is you are trying to identify low-hanging fruit. Now, low-hanging fruit are tasks that have no dependencies. They depend on nothing and nothing else depends on them. Now, as a rule, these are going to be at the very end of your workbook. They're going to be tasks in sections 5, 6. They're going to be things like optimize the network, configuring the services, and so on. This is usually scary stuff. It's usually scary stuff because how many times in your life have you configured sampled NetFlow export in version 9? Well, I've done it once, maybe twice in my life in real network. In the lab, I have done it maybe 3 or 4 times. Me, who is a CCIE instructor. How many times have you done it? See, that's the danger with these services, because there are so many of them. There are hundreds of services that you can run on the Cisco router. I wouldn't be surprised if we can actually run a full-blown mail server on Cisco router. Now, not that they will ask you to configure it, but you probably can run a mail server on Cisco routers. I haven't actually tried it. It's a good thing to investigate. I know for a fact that you can run a DNS server on a Cisco router. So these things in the end are scary because we are not very familiar with them. But they are also easy stuff, because in order to configure DNS server on Cisco router, for example, do I actually have any prerequisites other than router being powered on? Not really. I'll need to have a loopback interface, usually check, and then I just need to configure it. Or to configure NetFlow export. Yes, in real life you need to have a server that is going to take those exported flows, but on the router, do I actually have any prerequisites to configure? Is there any way of me verifying that NetFlow export works, which is UDP, by the way? No. Even if the server doesn't exist in the network, I can still configure it. QoS, for example, is one example of low-hanging fruit, because it doesn't really have any prerequisites to be configured. You might have prerequisites in order to verify it, to see if it operates correctly, but to configure it, there are really no prerequisites. Embedded Event Manager, usually no prerequisites. To configure the syslog, the logging features, to configure the anything to do with SNMP, no prerequisites. Yet, this is something that causes people, in most cases, to actually not pass the test, to fail the test. Why? Because when you're going through these tasks, you're going to be working section 1, section 2, and then you might be working on something here. And then by the time you reach these, what I call low-hanging fruit, you're out of time. Now, those students who are prepared for the test, that they know how to do the time management, they're going to be going through section 1. And mind you, section 1, the layer 2 section, is the most annoying, most boring, most tedious section in the lab, because it involves a lot of repetitive work. Switch port mode access, switch port access VLAN, switch port mode access, switch port access VLAN, etc., etc. And you are just doing the same thing over and over and over again. It's tedious, boring, and time-consuming. Now, when you have something that is tedious, boring, and time-consuming, what are you going to do? You're going to try to get through it as fast as you can. When you are hurrying, you are going to be more likely to make mistakes, so might be losing points there. Then you're going to hit section 2, and you're going to be dealing with routing protocols, you're going to be dealing with this and that, and it might be particularly tricky redistribution scenario. And what are you going to do? You're going to notice that you're spending too much time in this section, and you're going to hurry through it. When you hurry through it, you're going to make mistakes, potential for losing points. And then you're basically going to be chasing through the lab in order to reach this point so that you can actually do all the tasks and not run out of time. Well, this is why I suggest my students, and some people who have actually listened to me were very successful in the lab. I suggest that you do lab a little bit upside down. Once you have read through it and you have identified these low-hanging fruit, do those tasks first. I know for those of you who are going through our labs, who have gone through the training material from us or our competitors or whomever, this sounds like a very unusual suggestion, because we always tell you, make the core of your network functional before you move on to something else. And now I'm telling you, no, don't do that. Here is why. Because imagine that you do this low-hanging fruit stuff first. And you get, let's say, somewhere around 12 to 16 points on the board before you even touch task number 1. That means that you are now going into the tedious, boring section knowing, hey, you know what, I already have 12 or 16 points in my table. I'm good with this. I'm moving on. I'm confident. You're going to take it a little bit easier. There is no reason to hurry now because you're done with that stuff. Now you're going into the layer 3 section, particularly tricky redistribution scenario. You're again fine with it because there is no rush for you. You are already done with that easy stuff. So do it first. Do the low-hanging fruit first. Watch out for the landmines and understand the big picture. Now, when you are done reading through the lab, you are basically going to start working on the tasks. Before you do any of the work, you should connect to all the devices and just do a very quick sanity check. Now, the sanity check is take a look at your workbook, take a look at what you have configured on your devices, and you are always going to have some pre-configuration. Every single device in your network will have at least a host name and one loopback address configured. Most likely all IP addressing will already be in place when you start the lab. Just make sure that what you are seeing on your diagrams, what you are seeing in your lab, actually matches what you are seeing on your equipment. If it doesn't match, it could be that Cisco has loaded the wrong lab for you. If that's the case, again, report to the proctor and they're going to load the correct lab on your pod. This has not happened for about a year and a half that I know of. I have not heard this reported by any of my students, but it has happened in the past, and I always warn my students about it, even though I talk to the proctors and they say that this particular issue that was causing this discrepancy is no longer in place, that they now have an automated process in place that will load the configurations and the content in the web server at the same time. Again, I've seen automation go very, very badly. So the sanity check just very quickly, and then do a quick, when you start working through your layer 2 and when you start noticing that there might be some hardware issues, this is the time when you should report any hardware issues. But mind you, you have at this point already gone through this. You have read the whole exam, you have seen the big picture, you have read through the landmines, you have identified the low-hanging fruit, maybe you have even identified the tasks that you know will be giving you a lot of trouble. So now when you go and report the hardware issues, you can actually do a meaningful thinking process while you are taking that short break.